Hello. This video from chapter 13 is to illustrate how to do the homework. In the homework, I'm asking you for some clearance fits and calculate the tolerances, the size tolerances for a hole in a shaft. And this video here goes along with the posting in there, which is about the example problem. Okay, so what I want to do is walk you through how to do one of these tolerance fit problems. Okay, so here's the example. Calculate the hole basis limit dimensions for the pin and hole as shown. The nominal size is 0.4375. That's a basic size. That is 7/16. And the fit is a running and sliding fit of RC5. So your first step is to find the appropriate table. Now, I've included the tables for you for the basic hole system tolerances in the Chapter 13 materials folder. So open up that table, it's just a PDF file, and look for the fit limits for RC5. Now once you have that, this is what you're going to find. So the first thing you want to do is you want to find the row here that corresponds to your nominal size. So in our case, it's 0.4375. It's going to fit in this row. And then next, we're going to look for the column that's associated with your fit. Now, per the problem statement, our fit is an RC5. Now, what you're looking for is this data right here. Okay, the first two numbers here are your clearances for the fit. So the minimum clearance is 1 2/10, that's 0.0012, and then the maximum clearance for this fit is 2 9/10 of a thousandths, which is 0.0029. And what you have in this column here is the tolerances for the hole. Now notice we're talking about a basic hole system, which means that the minimum hole has no tolerance. Okay, so your minimum hole for this example is going to be 0.4375. Now over here in the third column of interest is what the shaft tolerances are. Okay, so these numbers here for the hole and the shaft, those are based on 0.4375 nominal size. Now this next explains what we're trying to do. Okay, so the first column is the clearance. Clearance. Numbers in this column represent the clearance range between the shaft and the hole in thousandths of an inch. So the 1.2 represents the minimum clearance between the hole and the shaft of 0.0012. And the 2.9 in that column is 2.9 here. That represents the maximum clearance between the hole and the shaft of 0.0029. Now let's look at the second column. Okay, that's the hole tolerance limits, just like it's listed. Standard tolerance limits, hole, and then shaft. Okay, so hole tolerance limits. The number in this column represents the hole tolerance limits. So 0.9 represents the largest hole, which is 0.0009 deviation from the nominal size. Okay, so therefore your maximum allowable hole size is 0.4375 plus 0.0009. That gives us our maximum hole size of 0.4384. Now the 0 right here, that represents the smallest hole. Now again, we're talking about a hole basis system, which means that the minimum allowable hole size is the basic hole size. Okay, in this case, it's 0.4375. So then, in the next column, right here, we're talking about the shaft tolerance limits. So the negative 1.2 represents the largest shaft, which is negative 0.0012 deviation from the nominal size. So therefore, the maximum allowable shaft size is our basic size, 0.4375, minus the 0.0012, or in this case, 0.4363. And then the negative 1.9, that's this number right here, it represents the smallest shaft size. Okay, so that would be negative 0.0019 deviation from the nominal size. So in this case, it's 0.4375 minus 0.0019, or 0.4356. Okay. Graphically, this is what it would look like. Okay. We take numbers that were calculated before. The whole goes from 0.4384 to 0.4375. That's what we're showing right here. And then the shaft limits are 0.4365 to 0.356. That's what's shown here. And therefore, we can easily check our solution, okay, by taking the minimum clearance. Now, the minimum clearance is always found by taking the minimum hole and subtracting from it the maximum shaft. So that gives us our minimum clearance of 0.0012, which matches the 1.2 in the table. And again, that is our allowance, because that is the minimum clearance between the two parts. And then the maximum clearance between the two parts is you would take the maximum hole, allowable hole size, and subtract from it the minimum allowable shaft size to get 0.0029. So follow this example when you do your homework, and you should be fine. Thank you.